Welcome to the second lecture on basics of welding process. As we know, welding is an additive process wherein which the material is added wherever it is required. It is a heat generated process, that means to say we use heat to join. Right. So, heat is there, moment there is a heat affected zone. So, this heat affected zone affects the microstructure, which in turn affects the mechanical property of the given material, because we are trying to join. So, from that understanding, now we will try to go and look into three different processes which are falling under welding. So, the content of this lecture is going to be, we will study about fusion welding process, then solid state welding process and gas welding process. Where is this reference? If you go to the previous lecture, we have said classification of various welding process. There we have clearly mentioned fusion welding, solid state welding and gaseous welding. First, let us try to understand fusion welding. So, fusion means joining. It is the welding technique in which coalescence is accomplished by melting two part surfaces to be joined. In some cases, we add filler material to the joint. So, this is important. We studied about autogeneous, homogeneous and heterogeneous welding process. So, there we studied in depth joining between two parts without adding filler and with adding filler. When we talk about solid state welding process, it is heat and pressure are only used to achieve this coalescence. There is no melting of the base material occurs and no filler material is added. So, that is fusion welding process. I am just showing the difference between that is solid state welding process. I am telling you the difference between fusion welding and solid state welding. In the fusion welding process, they are again classified broadly into arc, resistance and oxy-fuel welding process. Let us try to understand the arc welding process. Electric arc welding process is one of the fusion welding process in which the coalescence of the metal is achieved by heating from an electric arc between two electrode and the workpiece. So, you have positive electrode, you have a negative electrode. So, this is negative, this is positive. So, you try to keep the workpiece attached to it and here is the electrode. So, from where the material comes and droops. So, when it droops, it is done by an arc. The arc tries to melt the electrode material and deposit. An arc is a sustained electric discharge through the ionized gas column called plasma. So, this whatever is happening here, it is basically there is a plasma phenomena getting happened. An arc is a sustained electric discharge through the ionized gas column called plasma between the two electrodes. When you try to take two different electrodes together very close by, then what happens? The electrons jump from the negative side towards the positive side. It jumps. The electrons are small, they are more in numbers, they start moving towards the positive electrode. When they are moving, they have a small gap in between. So, when they move, they try to hit atoms and electrons while they are traveling, and while this phenomena leads to ionization between the two electrodes. Once there is an ionized phenomena there is a plasma there. This plasma will further, the electrons continue to move, that leads to an arc, right. That is what we are trying to say. An arc is a sustained electric discharge What is the discharge? The electrons are moving from the negative towards positive, ions are moving from the positive towards negative. So, there is a ionization phenomena happening. So, that phenomena is plasma. Once there is a plasma, then that leads to an arc. To initiate the arc in arc welding process, the electrode is brought into contact with the workpiece. First they touch it and then they slowly pull it up. The touching it is short circuiting and then they slowly pull it up. They try to pull it up to such a distance such that the arc is continuous. To initiate the arc, first to start you touch and then pull. In an arc welding process, the electrode is brought into contact with the work and then quickly separated from it by a short distance, such that the plasma phenomena can happen. Very important. If we do not do that, then we are not following the process. For example, you see here, first they touch and then they pull. So, now this in turn, now you will understand, in the previous lecture we were trying to talk about short arc, long arc. So, what you want to deposit, how do you want to deposit, depends upon the arc length. Okay. You can try to do, you want to have a deeper penetration, you have a short arc. If you want to have a wide spread of material, a farther away. The electric energy from the arc thus formed produces temperature of around about 5000 degrees Celsius, 5500 degrees Celsius. The arc is very, very high. The arc temperature is very, very high. So, with this temperature, whatever be the material, you can melt. This creates a molten metal pool of workpiece and filler material in the welding zone. So, molten pool comes into existence. This molten pool, please go back and take an analogy from casting. You melt by arc and then you have a liquid pool there, that is the molten pool of the work and the filler metal in the melt zone. So, you can try to have only melting of the workpiece is possible. In the vicinity, you also keep a filler material. This filler material also melts. Now, one type of material melting from this side in the close vicinity and then the base material also melting. So, now this and this gets mixed, and for this mixing to happen, you have to have a flux and then you have to protect this from the rest of the atmosphere. You have a shield, right. So, the molten material is, this portion is completely molten material. So, you can see the electrode holder, this is the negative side, this is the positive side, right. So, you are clamping it to the workpiece, and as and when the electrode moves on top of the workpiece, melt phenomena is happening. This melt phenomena will allow over a period of time to settle down. Molten metal will settle down and it will get deposited. So, the direction of travel is given here. This portion is called as the arc portion and this is the work and this is the molten metal. Okay. So, now let us get into the power source. You can have, as I said, AC power source or DC power source. So, AC stands for alternating current and direct current stands for DC. It would be preferred to have a DC, but this DC has lot of losses. AC DC conversion, again it is loss. So, now people are trying to work on, why do not we start using direct AC and try to do the welding process. So, AC machines are recommended for ferrous metals and DC machines are recommended for other processes, right. So, here this is a transformer, so which is there inside the arc welding machine. So, this is the machine. Machines are portable today. You can have a robust machine and you can also have portable machines. These portable machines are used for on-site operation. So, inside this machine what is there is this transformer. So, in a transformer you have a primary side and you have a secondary side. The output of the secondary side is attached to the circuit or it is attached to the electrode and the workpiece. So, this complete setup is there. So, you have a current which is passing by, a voltage which is applied and then this is a secondary where in which we have these iron cores, the secondary EMF is created. So, you have voltage and current. So, it helps in joining. So, the main components of the welding machine is a transformer. So, you have a step up transformer, step down transformer. Depending upon your requirements, you can choose. So, here we can try to set two things. One is constant current mode setup is possible. You can also have a constant voltage mode. Though both you can try. So, that means to say I keep a constant current which is there and I keep fluctuating the voltage possible, or I set a constant voltage, I keep current fluctuating possible. Because if you see, these two things are in turn linked with the arc length, right. So, the main components of a welding machine is a transformer which converts a supply of low voltage and a high current. So, normally we use 80 to 100 volts and we start with 50 amperes to 880 amperes current. In some cases we can go even up to 300 amperes. So, this is in AC we try to talk about 80 to 110 volts. Current we try to talk 50 to 80 amps, right. Whereas, in DC the voltage goes low, we talk about 8 to 25 volts in DC, and then the current we try to talk about 50 amps and more. Depending upon your requirement you can do, depending upon the rod thickness, depending upon the thickness of the plate, the current is varying. Why current is varying? Current is nothing but a flow of electrons. More and more current flowing, more and more melting, right. And you can't have infinite current, because the entire system has to be accommodated so much. So, if you have a very high current, the transformer becomes very heavy. Moment the transformer becomes very heavy, there is lot of heat generated. That is why if you walk through some of the power substations, you will see large transformers. The biggest challenge will be, how do I cool it? More current, bigger the transformer, bigger the cooling agent. So, in welding also we have a similar situation. The transformer is smaller or larger. When you have a large current, large cooling. So, this is just to have a feel for some of the aspects which are there in the welding machine. The power consumption in AC welding is low as compared to that of DC. The arc stability in AC, it is many a times unstable, but since direct current you are giving, the positive and negative is fixed, you get more of stability. That is why it is preferred for lot of other non-ferrous materials we use. AC, since there is no transfer of AC to DC, the cost is less. In DC, you add that component. The weight in AC is very light, in DC is very heavy, because the transformer currents are heavy. So, the machine also becomes heavy. So, predominantly we are trying to say DC machines will have to be stationed somewhere, right. Efficiency, since there is no losses of conversion, this is very high as compared to this is low. And in operation, AC is noiseless as compared to that of noise. Where is the noise coming? The spatter, the arc, the spatter which is there creates the noise. So, it is non-ferrous metals cannot be joined in terms of using arc metal. DC we can try to use. Now, there is a question for you, why is ferrous used in AC and not in DC? So, this question is there. I leave it with you as an assignment. In the next lecture, I will try to give you the answer for it. So, the electrode used are only coated. So, here bare electrons can be used. What is this only coated? So, only coated means you have an electrode, then you try to have flux on top of it. What is the function of this flux? We saw last time. So, it will try to create homogeneity in pool, whatever it is. It can also try to react with the melt and create a gaseous shield possible. It will try to move the oxides or other impurities to the top. All these things are done by flux. So, this is flux. So, that flux is coated. So, in DC what you can do is you can pour it from outside. So, that is what it said, you have bare electrode only used. So, welding of thin sections not preferred, here it is preferred, you play with the current. So, miscellaneous, the work can act as a cathode, while electrode can act as an anode and vice versa. In AC it is possible, but here the electrode is always negative and the work is always positive. DC, since there is no transition, there is no swing, cycle change is not there. So, it will have negative and positive. Here you can do vice versa. Okay. So, now let us try to have little more understanding about the welding equipments. So, we talk about the welding electrode. So, as I told you prior, this is the electrode and bore end of for gripping of the electrode holder. So, this is there, and on top of it you have solid extruded cover, which is a flux, and then striking end you will have a rod, slow small projection there, or sometimes to the face it is there. So, what we do is first we try to touch the tip, break the flux little, and then you give a small exposure of the electrode, and then you can start doing it. So, if you look at it, this is the core wire which is there. We have said wire, or it can be electrode. Electrode means it is a single piece, right? It can be there, right? So, striking end, core wire, solid extrude, gripping part for the that electrode holder. So, the key considerations are current available, because the current has to pass through the electrode. If the electrode is too thin, very high current, it will melt. So, current availability in turn dictates the electrode dimensions. Base metal composition and thickness is also very important, because that in turn, if the base thickness is very high, so then you will have a solid electrode, thicker electrode. So, that is also very important. So, the welding position can be three types. It can be vertical, it can be horizontal, or it can be flat. So, the desired depth is very important. Corresponding to that, you try to dictate the number of passes or the thickness is chosen. Coated electrodes must be kept dry to prevent moisture oxide induced porosity. So, many a times in this coated, if you do not keep it or if you do not keep it in a environment, closed environment, or if you keep it in an open environment, there is a possibility of water humidity getting settled down. This water humidity, while heat is there, when it is deposited, will create moisture. This moisture will create porosity. So, this porosity will be on the top. So, it is better to keep all these electrodes in a desiccator, controlled environment. So, the type of electrodes, there can be two types of electrodes. One is called as consumable electrode, the other one is called as non-consumable electrode. What are consumable electrodes? The metal, suppose you have metal 1 and metal 2, it is metal 1 and it is metal 2 you have. So, in between you are trying to fill a filler, right. So, now what happens? The electrode is consumed and it is filled there. Okay. So, this is called as consumable electrode. So, you can have a wire type, wire is continuous, or you can have an electrode stick type. If you have non-consumable, let us go and see what is that non-consumable. So, if you look into it, so the electrode is used only to produce the arc. So, and then it is stable, nothing happens there, no melting happens there, but you will have a filler rod wherein which this material has to come inside, that material alone melts. So, then it is called as non-consumable electrodes. You can have a soldering rod, right. You can just heat it and the soldering rod melts and the solder just melts there and you can do. You can also do brazing. So, wherein which there is a filler which comes, there is a heat which is generated, the filler melts and it falls down here. The base metal, there is no change in heat, only this portion there will be flowing of this is a weld portion and you try to get it. So, consumable electrode, non-consumable electrodes are two basic categories. And I would also like to add one more thing. So, if you have a continuous wire, then the flux becomes a problem, because here you have a flux coating on top of the electrode. So, sometimes what happens is you will have the electrode like a pipe, tube. Between the tube, there can be flux material coming. That is also possible. One possibility is you coat, the other possibility is you push it through this part and then you can get, that is also possible. So, all combinations are there, creativity can be done and it is left to you to do it. And in some places what people do is they try to have an electrode and then they have a flux, right. In this flux they also have powders of metal or something. This is also used to create the arc. So, consumable electrodes, thin rod or wire, wire is for continuous, bare or flex coated, as I already discussed with you, melt to form a part of the weld. The coated electrode, mild steel rod with flux prevents oxidation, providing alloying elements and forms slag to remove impurities. Examples of shielded metal arc welding process, SMAW. So, there are two processes, shielded metal arc welding process or it is submerged arc welding process, SAW. Two different processes are there. So, here it is consumed. When they build a ship, it is consumed, submerged arc welding process. The electrode is consumed. When they do the heavy hoppers, it is consumed. In automobile, many a times the electrode is not consumed, only the filler material is consumed possible, right. So, there are two processes are examples for consumable. Non-consumable electrodes do not melt or form part of the weld deposit. Typically, carbon or tungsten electrodes with low depletion rates are used. Why tungsten? So, tungsten will be brought like a rod. So, tungsten has a very high melting point. So, this will not melt, but the filler which comes, which has a lower melting point, this is a filler rod which has a lower melting point, will melt faster and it will get deposited. This fellow will only create an arc. Example, gas tungsten arc welding and the plasma arc welding process. Here there is no consumption of electrodes. Electrode holder is very important. So, the electrode holder, through this you have to pass very high current. So, you have to be careful. The electrode holder holds the electrode with its jaw. So, this is called as a jaw. So, what happens is you try to put something like a cigar for a person you will try to have. So, what happens, you try to press this handle on the top, then this opens, then you fix an electrode, and here it will have very high current and voltage coming. So, that comes in contact. The jaw of the holder are made of metal and highly conducting and heat resistance, because there is a current which is flowing. The electrode holder needs proper insulation as electric current flow into the weld zone through it, proper insulation. So, this is insulation, you hold it by a hand. In the case when the jaw are subjected to very high temperatures, provision for cooling is also done. So, many a times what happens, in manual holding we do not have this provision, when it is automated we also have. So, why? High current, so cooling has to be done, otherwise this fellow will melt. So, the other thing is work table, this is the work table. So, generally when you do in lab classes, you will have a setup like this. So, there will be a work table. The table will have the negative, this is, if you take this as negative electrode, that will have the positive. So, the part to be welded are placed on the work table, which is flat, and here it is in the lab scale, flat can be kept. In situations it can be hemisphere, spherical, it can be double convex shape, that can be there. It is connected with the power source to give a particular polarity to the workpiece. An electric circuit forms when an electrode is brought in contact with the workpiece through the work table and the electrode holder. So, this completes the circuit, that is what we are trying to say. So, there are connecting cables which are also used. So, the connecting cables are used to connect the electrode holder with the power supply. So, this is in turn attached with this. This will have a connecting cable, and this will be attached to a socket where in the power supply machine you try to have it. So, it should be flexible through a facility, easy mount of electrode, properly insulated and capable of carrying high current. This is very important in welding. We always ask people, or the welder always uses a shield. Why is that shield? Because if you go back and look into the process here, you see there is lot of radiation which is coming. In this radiation, there is also UV radiation also coming. So, that has to be protected from your eyes, otherwise you will have eye irritation. So, this is why there is an important thing called as a shielding here, which generally we do not use it in forging, in casting. In machining also we just try to put it as to protect ourselves, but here it is a compulsion that you have to shield your side. So, weld shields are used to protect the eyes for the welder. The electric arc welding generates ultraviolet radiation which may cause permanent damage to the eye. Friends, whenever I do experiments in my lab and when I do welding by myself for developing some setups, the shield, if I do not use it properly, it irritates and I do not get a proper sleep. So, the UV radiation affects your eye. So, therefore, the weld shields are used for arc welding should be opaque to ultraviolet. This is a chipping hammer. Why is that chipping hammer very important? As we have discussed till now, when you add a flux, there it's a possibility that it creates an oxide and then this oxide is moved to the top. Oxide are unwanted metal, so you have to chisel it off. So, you use this chipping hammer, tuck, 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 you hit it. Or the other way around is when we are trying to use shielded gas arc welding, or when we are not using a shielded gas arc welding, you are continuously welding, the oxides will be formed on the surface. So, that has to be avoided. So, we use sharp edge. This is a flat one, this is a pointed one, which you try to give a impact load. That is why it is called as hammer. So, it is done and then you try to do it. Then it is filler metal. Filler metal used with the non-consumable electrode enhances welding property. Non-consumable electrode where we use tungsten for creating the arc, filler material used. They may be bare or coated flux. The coated type provides oxidation protection, which we have already seen. The filler material composition typically, this is very important, typically matches the base material such that whatever alloy adding to be done, we do it to improve the properties. Flux material we have discussed, so it avoids oxidation. Coating is done inclusive or exclusive. The most important, this point is very important, ingredients are cellulose, mica, silica, titanium dioxide added in the slag formation, while magnesium oxide and potassium silicate are used as stabilizers. So, we use flux for stabilizing, we use flux for oxidation or slag formation, which is on the top. And thank you very much.